Back to similar triangles and similar shapes in general is what we've been doing, but we're going to focus on similar triangles in this video and how to show that they are similar. So I mentioned before that if you're trying to prove congruent, AAA is a no. That does not work. But if you're just trying to prove similar, then AAA is a yes, because that's the definition of similar. Really, similar means that all the angles are equal and therefore all the sides are proportional. Now, it's actually a little bit less stringent than AAA to prove that two triangles are similar. Let me show you what I'm talking about. Say you've got this triangle and this triangle. They look like they're similar. They look like the angles would be equal. Obviously, this one's bigger, but that doesn't matter. And similar, the sides are proportional, not equal. So let's start checking. Say we check the bottom left-hand corner, and that is an 80-degree angle, and so is this one over here. So far, so good. Then we check the bottom right-hand corner, and that's a 40-degree angle here, and same with over here. That's a 40-degree angle. Okay, so now we've got two on our way to AA. We're 2/3 of the way there. We don't even have to check the third one because of triangle sum theorem. We know what the third one's going to be in both of these triangles. The third one's going to be 60 because we've got 120 so far. The third one's got to be 60, and if these two are the same, then these two are 120, so that has to be a 60 also. So you really only need two A's to prove that they're similar, because if you have two, you automatically have the third because they have to add up to 180. Hopefully that makes sense to you. I think that's pretty clear. If these two add up to 100, that has to be 80. If these are the same as those, then they add up to 200, so that has to be 80. If you have two, you've got the third. So you only need to prove two. Now, using that, you're going to be given pictures of triangles, and you're going to have to find two equal angles in them. One of them is the hourglass, I like to call it, picture. Hourglass picture, can you find two angles that are the same? Well, you could find one right here. Those are vertical. And you can't get any more unless you have one more piece of information. And that piece of information would be that these two lines are parallel. Some of you might have been already thinking alternate interior angles, but remember, alternate interior angles are only equal if the lines are parallel. Now that you know the lines are parallel, then yes, now you have alternate interior angles here and here, and that's enough to say that those two triangles are going to be similar. I mean, you could have used alternate interior on these over here. So really, because they're parallel, it's easy to get all three, but you only need two, so maybe you didn't want to use the vertical. Maybe you just wanted to say that A and B are alternate interior, and C and D are alternate interior, so therefore the two triangles are congruent, or I'm sorry, similar. And that's what you have to do in the do problems today. You have to say, are the triangles similar? And if they are, give me the reason why both the angles you chose are congruent to each other. So in this problem, if you choose these two are congruent to those two, you got to say alternate interior for both pairs. If you would have used these two angles here and say that one, you got to say alternate interior for those pair, and you have to say vertical for these pairs. So I don't care what two angles you pick, as long as you can show me that they definitely are congruent. By either alternate interior or vertical in a picture like that. Now you could have a different type of picture. Maybe you'll have a picture that looks like this. Does this look familiar? That looks like the mid-segment problem. Well, we don't know for sure if it's a mid-segment because I didn't tell you that it's exactly connecting the midpoints of these two sides. I just said it's parallel to the bottom. Like I could have drawn the line way up here and said that it's parallel. That's clearly not a mid-segment. This section is not the same as this section. But just because it's not in the middle doesn't mean it can't be parallel. Those two lines could still be parallel. You could draw a parallel line anywhere across here. Only in one particular spot is it right in the middle of these two. So only one particular one of these parallels is a mid-segment, but the mid-segment's not really special in this case What's special is the fact that these lines are parallel. So let me label these points. We'll call this A, B, C, and we'll call this D and E. And I'm asking, is triangle ABC similar to triangle ADE? And if your answer is yes, then you need to give me two angles that are congruent to each other, because angle is enough to prove that they're similar. Well, one of them is a shared angle. A is in both triangles. If you split these into two pictures, and this is ABC and this is ADE, then A is in both triangles. You're sharing the angle A. So there's one angle, A, and you could say it's a shared angle, which is technically called the reflexive property when you share something. Reflexive, it's like when you look in the mirror, it reflects the same thing is equal to each other. Okay, then you're going to have to use the parallel lines, just like we did in the last picture, to get your other ones. But here it's not going to be alternate interior. What's it going to be? Imagine if these lines are extended. What does this start to look like? It starts to look like this picture. And we're looking at these two angles right there. Those are corresponding angles. Corresponding angles. So this one is congruent to that one because they correspond. They're both in the upper right-hand corner of these four angles. You got four angles here. They're in the upper right-hand corner. Upper right-hand corner. They correspond to the same corner. Corresponding angles, and you can make the same argument over here on the right. Those are also corresponding angles. So these two triangles, if you draw a parallel line across the triangle, parallel to the other side, you've drawn similar triangles every single time. Because as long as they're parallel, you're going to have corresponding angles. You're going to have two of them. That's all you need is two angles. And you've got similar triangles. So they're always similar when you have a parallel line, whether it's the mid-segment or not. They're similar. So there's two examples of how you can use AA to prove that triangles are similar. You'll have to do stuff like a couple problems like that in the do section today.